Hello children, how are you? Welcome back to Insight Engine Academy. Now we have another session of chapter force from class 8. Previously we have discussed types of forces, contact force, non-contact force. In that all the examples we have discussed. Now in this class we are going to talk about net force. So net force is very important concept, because generally we people are thinking when table is present on the floor, table is at rest. So generally what do we think? There are no forces exerting on that table. That means there is no force exerting on the table. But in reality it is not happen. In physics, to understand the net force concept, so you have to understand all the types of forces. That is why we have discussed previously. We have discussed normal force, tension force, gravitational force, all those kinds of forces. Because when this table, this is the floor, here we have the table, so this is the table, right? On this table it seems to be rest. It is at rest only, but it seems to be there are no forces are acting on this table. But in reality there are forces on this table, forces exerting on this table. Already we have discussed previously, this table is pulled by the earth. This earth exerts some force on this table, that is gravitational force. So gravitational force on this table towards down, W is equal to mg. And this table take the support of this floor. That means the table in contact with the floor. Whenever there is a contact between the two bodies, which force come into play? As we have discussed in the previous video, normal force. So since there is a contact, because of the contact between the table and this floor exerts the force on the table in upward direction. That is what? Normal force. So how many forces are acting on this table right now? Two forces are acting. But even though table is at rest, table in equilibrium state. So what do we call this? Technically we call this net force is zero. We are going to discuss another example. This is surface. This is the table, right? Here I have placed one book. Now how many forces are acting on the book? One is gravitational force towards down, and this table exerts one force on the book in upward direction, as we have discussed yesterday. So two forces are acting on the book. Total how many forces are acting on the book? Two forces are acting on the book. But if you take the table, if you consider the table as a system, how many forces are acting on the table? Gravitational force, downward direction, and this table is on the floor, right? So this floor exerts normal force on the table in upward direction. And the book which is placed on the table, the book also exerts some force on the table, because when I kept the marker on my hand, this marker exerts some normal force on my hand in downward direction. My hand exerts normal force on the marker in upward direction. In yesterday's video, normal force we have discussed. Whenever two bodies are in contact, compulsory there exists a force between two bodies. Two bodies exert force one on each other in opposite direction. Here table exert force on the book in upward direction, the book exert force on the table in downward direction. So another force also acting on this table, that is normal force by book. Here the normal force by floor. Two normal forces are existing, but one normal force due to the contact between the table and the floor, that normal force is upward direction. Another normal force due to the contact of the book and the table, here book exerts normal force in downward direction. There are two different normal forces, and this normal force and this normal force is completely different. That is why I have shown this is with the n and this is with the n1. N and n1 are not equal. These both are different. The magnitudes are different. So here whenever there is a body, whenever there are bodies, are in contact, forces exert one on each other. I'll explain one more example. I have considered one block. Let's say this is block A, and I placed another block B, and I placed another block C. Total how many blocks we have? 3 blocks. The block A is on the floor. Now how many forces are acting on the block A? First we will discuss block C. How many forces are acting on the block C? So this total system is at rest now, not moving. See, now the forces acting on the block C we are talking about. There is a gravitational force on every body. Gravitational force, it is common on every body. So gravitational force exerts in which direction? Downward direction. So this is the one force acting on the block C. What is the other force acting on the block C? this block B and C both are in contact, so this block B exert the force on the C in upward direction perpendicular to its surface, that is called normal force. So here normal force acting on the block C. So due to these two forces are balanced, this block is at rest. Okay, right. Any other force acting on the block C? No, there are only two forces are acting on the block C. One is downward gravitational force, another one is upward normal force. Now we are going to talk about block B. Where is the block B lie? This block B lie between the C and D. Block B is in contact with A as well as block B also contact with C. So block C contact with only B. That is why there is only one normal force that is exerted by the block B on C. In which direction? Upward direction. Okay, right. Here this block B in contact with one of the surfaces is contact with the block C, and the other surface is contact with the block A. So this block B is contact with the C and A. Then tell me how many forces acting on the block B. This is a block B. So usually there is a gravitational force in downward direction. W is equal to mg. This is common. And the other force, this on block B, this block A exert a normal force in upward direction. So this is a normal force by block A on block B. So the normal force due to the contact between these two, let's say N1, and the normal force due to the contact between these two is N2. That means block B exert N1 force on the block C. Block C also exert N1 force on the block B. Okay, so both are exerting force one on each other. What is that value? I take N1. So block B exert force on block A. Block A also exert force on block B, normal force. Okay, so what is that force I have taken here? N2. So here this force is N1 and here N2. These both are different. Okay, right. Now this block C exert a normal force on block B. This block C also exert force on the block B. What is that force? Normal force. What is the direction of that normal force? Downward direction. This block A exert the normal force in upward direction due to the contact between the B and C. A is at the B is in the middle of the C and A. A is at the bottom, right? Block A is at the bottom. So B in the middle of the C and A. So block A exert the normal force on the B in upward direction. Block C exert the normal force on the B in downward direction. So this is a normal force exerted by the block C on the block A. Okay. So what is that force? That is generated by N1. So another force is acting on that. What is it? So total how many forces are acting on this block B? 3 forces are acting. Okay. I hope you understand. Coming to block C, there are only 2 forces are acting. What is the reason? Because this block C contact with only block B. Okay, due to this block B, the force on the block C in upward direction, that is normal force N, and gravitational force is as usual common everywhere it is happened. So gravitational force is downward direction. There are only 2 forces on the block C, but block B in contact with A as well as C. Due to the contact of the B and C, here one normal force exerted and here also one normal force. 2 normal force exert due to the 2 different surfaces are of block B contact with C and A. So here the normal force, let's say N1, and here the normal force, let's say N2. So on the block B, gravitational force is common. Okay, and other force, this block A exert normal force on the block B in upward direction. This block C exert the normal force on the block C in downward direction. So total how many forces are acting? 3 forces are acting on block B. Now let us consider block A. On the block A, how many forces are acting? First we have to understand this block A connect with what surfaces. This block A is connected with the surface of this block B, and this block A is on the floor. This is on the floor. Okay, so this floor also exerts a normal force on the block A. In which direction? Upward direction. Let's say that normal force is N3. Okay, so gravitational force is common. So one is gravitational force, W is equal to mg. The other one is this floor exert normal force in upward direction, that is N3. And any other force? Yes. Due to the contact of this block A with the surface, normal force is N3. Due to the contact of this block B and block A, the normal force exert on this is N2. Okay. So what is the direction of that normal force on the block A by the block B? Downward direction. So here another normal force is acting, that is N2. So total how many forces are acting on that? 3 forces. But whenever blocks are placed one upon each other, whenever we see, it seems there are no forces are acting, but in reality, coming to physics, if you understand, these are all the internal forces. Some of the internal forces are there, some external forces are there. Gravitational force is external force. These normal forces are the internal forces. So this is a complete concept related to the forces. Okay. By this, what do you understand? What we see is not real. In reality, when object is at rest, don't think there are no forces are acting. Actually, forces are acting. Okay. But object is at rest. Why it is rest? Because here one force is acting downward direction and the other force is acting in upward direction. These two forces are equal in magnitude but direction is opposite. That is why the net force acting on the two bodies is 0. Here two forces are acting towards down and one force is acting towards up. Okay, this upward force is balance the downward two forces. These two forces are equal to this upward force. That is why this block B is at rest. So what is the net force? Net force acting on the block B is 0. Here also, this A is balanced. Okay, on A balanced forces are acting. The forces are acting in downward direction are balanced by the forces acting in upward direction. The net force acting on the block B is 0. That is why it is also at rest. So when object is at rest, what do we have to understand? Forces acting, but those forces are balanced. That is why net force acting on them is 0. So for better understanding net force concept, I am going to explain one example, tug of war game. What is tug of war game? There is a rope, some group of people are pulling this way and some other group of people are pulling from another side. So both are pulling the rope opposite direction, right? So one group of people is pulling towards right and the other group of people are pulling towards left, right? Then which group of people pull that rope with more force, okay, that group of people will win the game. That is tug of war game. I hope you have seen. This is funny and a very interesting game, right? So because many people are involving in that game. Okay, so games really they are connecting the people. Many people are connecting during that game, right? So here you see, and let's say this is a group of people are pulling the rope. They are exerting force at the rope. Okay, this is group A. Let's say this is group A and the force exerted by the group A is F1. They are exerting F1 force. Okay, so they are exerting force in which direction? This direction, right side. And the other group of people also pulling the rope. Okay, and these group of people are pulling the rope towards left. Okay, so this is a group B and the force exerted by the group B is F2, but the direction is opposite to the group A people. Okay, so the force exerted by the group A towards right and the force exerted by the group B towards left. Two forces are acting at the rope. Now, how many forces are acting at the rope? Two forces are acting at the rope. Let's say this group of people are exerting 50 newtons of force. 50 is the magnitude, Newton is the unit of the SI unit of the force. So F2 also 50 newtons, let's say. Both teams, team A and team B, both teams exert the same force at the rope. Okay, then think who will win the game? Nobody. Why? Because the rope is at stable, okay, equilibrium state. It doesn't move either towards left or towards right. Right? In this case, what is the net force acting at the rope? The net force acting at the rope is 0. Because two forces are acting, but they are acting equally but in opposite direction. That is why net force acting on the rope is 0. How do you calculate the net force? Generally, we calculate the net force. Okay, we have to add the net forces. Net force is nothing but it's a sum of the algebraic sum of all the forces acting on your body. Okay, what is the definition of the net force? It is algebraic sum. Sum means addition. SUM. Sum, addition. Algebraic sum of all the forces acting on your body is called a net force. Here, at this rope, how many forces are acting? All the group of people, different forces all together we say F2 and all these group of people together we say F1. Total, let's say 2 forces are acting on this. Okay, now we are going to add these 2 forces. Okay, so first I will write the definition of net force. The algebraic sum of all the forces acting on a body is called a net force. Is called net force. Sum means what? Addition. Now we are going to add the forces. Now at the rope, tell me how many forces are acting? Two forces are acting. One is F1, other one is F2. Now we are going to add those forces. One is F1. Okay, I'm going to add those forces. One is F1 plus. We are adding, right? But while adding, we have to understand one important thing. Are these forces acting in the same direction or opposite direction? Opposite direction. When forces are acting in opposite direction, we have to add the forces like this. One force acting in one direction, the other force direction is opposite to the first force. That is why we have to take the negative sign. Why we have to take the negative sign? Because here direction of the forces are different. For example, if you take the block, let us imagine two forces are acting on this block. One is F1 force, the other one is F2 force. How many forces are acting on the block? Two forces are acting. In which direction? Same direction. Okay. When two forces are acting on the block in same direction, to find the net force, what is net force? It is the algebraic sum of all the forces acting on a body. We have to add all the forces. So two forces are acting on this block. So F1 plus F2. Okay. But if you consider another block here, let's say one force acting on the block is F1 towards right side, the other force acting on the block towards left side. This force, F2 force acting on the block towards left, F1 force acting on the block towards right. Now, how do you calculate the net force? What is net force? Net force is the algebraic sum of all the forces acting on a body. Here on this body right now, according to this diagram, two forces are acting. Now we have to add them. So F1 plus F2, this is very good. But here two forces are acting in the same direction, that is okay. But here two forces are acting in opposite direction. That is why one of the forces is taken as negative. Then plus into minus, minus. Now F1 minus F2. So net force is the difference of the two forces when forces act in opposite direction in the same line. When two forces act in the same direction, net force equal to exactly sum of the forces only. But whenever two forces are acting in the opposite direction, the net force equal to difference of those forces. Okay. So I hope you understand the concept. So this concept is very, very important. Here two forces are acting in same direction. That is why net force equal to sum of the forces. Here also sum of the forces only. But as the direction of one force is opposite to the other one, the negative sign is taken here. Okay. Negative sign is taken. That is why plus into minus is equal to minus. This way this is difference. Okay. Now coming to here. Here two forces are acting in same direction or opposite direction? Opposite direction. Whenever two forces are acting in opposite direction, how do you calculate the net force? One force is taken as positive, the other force is taken as a negative. That is why net force is equal to now F1 plus into minus F2. For example, now what is the net force acting on that? 50 newtons minus 50 newtons. Then net force is equal to 0. Now what is the net force acting at the rope? 0, because team A pulling the rope towards right side with exerting 50 newtons of force at the rope. Team B pulling the rope towards left side by exerting 50 newtons of force at the rope. Right? As the forces are, magnitude of the forces are equal, the net force becomes 0. Okay? And why they become 0? Because these two forces are acting in opposite direction. That is why one of the force is taken negative, then plus into minus, minus, the net force acting on them is 0. This is very, very important concept. For example, let's say team B pulling at the rope with 100 newtons of force, team A pulling at the rope with 80 newtons of force. Tell me who will win the game? Obviously team B, because the rope goes towards team B. Now net force is acting at the rope. In the previous case net force is 0, but in this case there is net force at the rope. How do you calculate that? same concept. F net force is equal F1 first force, okay? But here, which is the larger force? Second force is the larger force, F2. So always whenever you find the differences during calculation of the net force, you have to subtract the smaller force from the larger force. Which is the larger one here? 100 newtons. So greater force minus smaller force, 100 F2 plus minus F1. F2 is 100 minus F1 is 80. Okay, so total how many newtons? 20 newtons towards B, towards team B. Here force has direction, right? Already we have discussed force is a vector quantity. Here the net force direction is towards team B. So this group team B win the game. For example, now team A exert 150 newtons, team B exert 100 newtons. Then tell me what happened. Now how do you calculate the net force in this case? In this case we calculate the net force this way. So net force is equal to, which is the larger force among these between these two? 150 is the larger force, 100 is the smaller force, right? So 150, otherwise first you have to write formula F1 plus F2, but between these two F2 is opposite to the F1, that is why we are taking negative sign, okay? Then F1 plus into minus F2. F1 value how much here? 150 minus F2 value how much here? 100. Then altogether we are getting 50 newtons. Now net force is 50 newtons. Towards which direction? Towards A. Now team A people will win the game. Okay? So this is a very important thing. I hope you understand how to calculate the net forces. Okay? See here. Now we are going to calculate the net force of these three blocks. Here how many forces are acting at the block? Two forces are acting. One is gravitational force, other one is normal force. So this block is at rest, not moving. So what is the net force acting on it? 0. Okay. Then how do you calculate the net force now? So net force is equal to gravitational force minus normal force. Okay, so gravitational force plus minus normal force. Why? Gravitational force acting towards down, normal force acting towards up. As the direction is opposite, we have taken negative sign. So W plus into minus N. So these two forces are equal in magnitude. Okay, magnitude of the two forces are equal. W is equal to N. Both are same. Then in the place of W, N can be written. In the place of N, W also can be written. So finally W minus W is equal to 0. Net force acting on it is 0. Okay. Now this block B also at rest. That means net force acting on the block B is also 0. Then how do you write the equation for this? So here two forces, okay, acting in the same direction. When two forces are acting in the same direction, we have to add these two forces. Here W plus N1, W plus N1 together acting towards down, but this N2 acting opposite to these two forces, that is why plus into minus N2. Okay, now net force is equal to W plus N1 together, it is acting towards one direction, plus into minus N2. So these two forces are equal to these two forces because these two forces are balanced by this particular one force. That is why net force acting on it is 0, because the value of these two forces, the magnitude of these two forces equal to the magnitude of N2. Since W plus N2 is equal to W plus N1 is equal to N2, then net force acting on them is 0. Now we are going to write the equation for this. How do you write the equation? Net force is equal to total how many forces are acting? 3 forces. Among these 3 forces, 2 forces are acting towards down, right? The another force is acting towards up. As these 2 forces are acting towards down, we have to add them. So because when 2 forces are acting in the same direction, previously I explained here with one example. Okay, so these 2 forces are acting, then W plus N2 together acting in the same direction, it is considered as one force. Resultant force of these two is 1. and the other force acting opposite to these two forces. That is why sum, but as they are acting opposite direction, we have to take negative sign N3. Okay, so W plus N2 plus into minus minus N3. Okay, we know that this W plus N2 is equal to N3. That is why net force is equal to 0. These two forces, magnitude of these two forces which acting towards down is equal to the magnitude of the N3. That is why net force acting on them is 0. Whenever objects are at rest, there are forces acting on them, but all those forces are generally balanced. That is why when object is at rest, the balanced forces acting on them, so net force act on that objects is 0. Even when object is moving with uniform motion also, the net force acting on them is 0. So now we are going to talk about a uniform and a non-uniform motion and how to calculate the net force with the help of the free body diagram. So this is generally called a free body diagram. So free body diagram is a diagram, okay, which shows relevant forces acting on a body. So please note down this example, and net force definition is given there. Okay, some examples are these. Some other examples also we will discuss. Meanwhile, please note down this.